This lecture, guys, is on stoichiometry. This is your last lecture for the year. Basically, this kind of plays into what we've been learning previously about moles. You're going to see moles here. You're going to see mass here. You're also going to see some volume and you're going to see molecules as well. So this is very similar to what we just did last section. It just takes into consideration in a whole formula. So you guys have seen a formula like this before. You actually balanced it. And if you remember, because it was all about you want to have equal sides on both sides due to the law of conservation of matter, which says matter cannot be created nor destroyed. So if we look at this formula, for example, we see a 2 in front of the H2. So we see a 2 right here. What does this mean? It means that for every 2 moles of H2, okay, there is only 1 mole. Since O2 has no coefficient, we need 1 mole of O2. And what does this produce? Remember, the arrow means equals to, or what these two molecules produce. They produce 2 moles of H2O, and this 2 coefficient means there's 2 of H2O. So what are we using? Why did we look at that formula? In stoichiometry, we use a complete formula, and from that complete formula, we use something known as mole to ratio from a balanced equation. And in this case, we are using information about a known molecule in the formula to determine the information of another known molecule in the equation. And stoichiometry is used daily by people like pharmacists, nurses, because these we need to make sure that we have the correct amount of a molecule in order to, for example, give a drug to a patient. If we don't give enough of this molecule, will we still perform the end product, which is obviously the drug or the vaccine or things like that? So stoichiometry is used by everybody kind of in a medical field related. And I know in this class we have a lot of people that are looking into nursing, doctors, pharmacists. So this is something that you will definitely see in the future. So this week you will see something like this in your Google Doc, in your Google Classrooms, and in the email that I will send. This is kind of the same cheat sheet similar to the cheat sheet you used before. If you remember before, it was just kind of like half of this cheat sheet. You use mole to mass, mole to molecules, and just basically those 3. But now we have added 2, volume of gas and volume of solutions. And now, because we are doing, like I said before, we're going from a known molecule, so known A, to an unknown, okay? And now you're traveling from left to right. And you're going to be traveling depending on where you start with. You're going to start in one of these, or you're going to start here, and you're going to move to the unknown. And here, like it says before, please pay attention to everything here. The molar mass is the mass from the periodic table. You're going to use coefficients from the balanced chemical equations. Note, key thing here is every single equation is going to be balanced for you. There's no need for you to balance it. So you're going to use the coefficients. The molar mass, all this stuff is kind of the same thing that you've seen before in the other sheet. So let's take a look at an example. So please have this out. What I suggest is if you don't have a printer at home, copy it down in your own. I made this myself. As you can see, this is not from online. I actually made this myself. You can make it yourself too. You just need a blank sheet of paper and you can make this yourself, copy it down yourself. So let's take a look at this. It says, if 4.2 moles reacts completely with O2, how many moles of O2 are needed? I know it sounds like a lot. This is one of the simplest problems that we have. And this is the chemical equation you're using. You're using the water. 2H2 plus O2 gives you 2H2O. So we're going to take what we have and what we know, which is 4.2 moles of H2. 4.2 moles of H2. This is what we know. This is what we have. Okay, so we have 4.2 moles of H2. That means, guys, that we have 4.2 of this. We have 4.2 of this. Now, what do they want to know? They want to know how many moles of O2 are needed. So how many of this do we need? So we are going to go from this to this. We want to know how many moles of this do we need. We have 4.2 moles of this. How many moles of O2 do we need? Now, what do we know then? Where do we start here? We are starting in the mole, okay? Because we are starting with 4.2 moles of H2. This is the known. This is what they gave me in the problem. What do I want to find out? I want to find out moles of O2. Okay, I want to know the moles of O2. That means that I'm just jumping from 1 to 1. This is a one-step problem. You're going to use the coefficients from the balanced chemical equation. So how would I set this up? Well, I want to get rid of moles of H2. So moles of H2 is going to go at the bottom. What do I want? I want moles of O2. That's going to go at the top. And the numbers here that are going to go here are from my balanced chemical equation. So the coefficient for H2 is 2. So that's going to go at the bottom. The coefficient for O2 is 1. So that's going to go at the top. I got rid of moles of H2 this way. I times by the top, divide by the bottom. So I am simply going to do 4.2 times 1 divided by 2, which gives me 2.1. Again, I want 2 sig figs because 4.2 only has 2 sig figs. And it would be 2 moles of O2. This was a popular question, is how many sig figs do I use? You use the sig figs that they give you in the problem only. So only in the problem. Don't use these sig figs, the coefficients of sig figs. You're only using what they're giving you of the known. And this is the final answer. That's it for these, okay? So again, it might look very scary. It might look like a lot, but these are just mole-to-mole problems. These are pretty easy. You're just looking at coefficients of the problem. We don't have a device to measure moles. There's no glassware, there's no scale that measures moles. So how can we use moles in order, or how can we convert moles into a unit that we can use, that we can measure, things like that? So like I said, we can't go to the lab and countermeasure moles, so we need a way to work in a measurable unit such as grams and liters. So if you remember, we worked with mass. How did we find out 1 mole of, let's say, H2O? We looked at the mass in the periodic table. So that's what we're going to do next. All right, so how about moles and mass? So like I said before, moles is not a unit that we can measure really in a lab. So obviously mass definitely is, we can just quickly grab a scale and throw in a couple things in our scale to measure out the mass. So the question here is, how many grams of AgCl will be precipitated if 0.4 moles of AgNO3 is reacted as follows? So again, lots of different words here, but it's the same thing. You're going to start with moles here, and what is it telling you? You have 0.45 moles of AgNO3. So you look in here, okay, so that means I have this much of this. I have 0.45 moles of AgNO3. What am I trying to figure out? I am trying to figure out AgCl. That's this. I'm trying to figure out this, but now I want this in grams. I have this in moles, but I want the amount of this in grams. So how do we start? We always start with what we're given. So let's write out. We start off with 0.45 moles of AgNO3. Okay, that's what we start off with. So that means that if we're starting in mole island again, we're starting here. Where are we moving now? Well, we're going to figure out eventually the moles of AgCl, and then eventually we're going to go to the mass of AgCl. How come we can't go from mole to mass? You might think, well, can't we go here? We can go from mole to mass here. Well, in this case, if we went this way, we went up here, we would just figure out the mass of AgNO3. That's what we would be doing. We don't want the mass of AgNO3. We want the mass of AgCl. And because we want the mass of AgCl, and which is the unknown, we have to go to this mass instead. So first we have to turn that mole into the moles of AgCl, and then the moles of AgCl we can turn to the moles, a mass of AgCl. This is all of this stuff here on this side is the moles, the mass, the volume of AgNO3. Okay, if we go here, we're just figuring out AgNO3. We have to go this way. And the only way we can cross into the other side is by using the coefficients from the balanced chemical equation. So we want to get rid of moles of AgNO3. That's going to be at the bottom. And we want moles of AgCl. That's at the top. Again, we have to go from mole to moles. This is the only connection between the known, which is what you're given in the problem, and the unknown, which is what they're telling you to figure out. So we are going to use the coefficients. As you can see, we have a 2 for AgNO3 as a coefficient. We have a 2 for AgCl as a coefficient, all right? And by doing this, we are simply going to moles of AgCl now. Now, again, if you know this, if you do times 2 divided by 2, that means that you're just going to get 0.45 moles of AgCl now. So now you are at AgCl. You're going to keep going. Now, there is a quicker way you can put this all in one. I'm just breaking it down for you right now. I'll do the other one as a all together, but just for the first one here, I want to do it broken down. So now that you have moles of AgCl, you're like, okay, now I know AgCl, but now I want the grams of AgCl. That means if you look here, you're going to go up. So you're using this top one right here. Your fraction is going to be molar mass over 1 mole. And remember, the molar mass is the mass from the periodic table. So we got rid of moles of AgCl. That's going to go at the bottom. And now we want grams of AgCl. And it's going to be 1 mole, as you can see, 1.00 over the molar mass. So the molar mass is what we find in the periodic table. So we have to find Ag, which is 107.87, plus Cl, which is 35.45. Okay, so Ag, like we said, oops, let me write it actually over here. Ag is 107.87. Cl is 35.45. Guys, be careful with subscripts. A lot of you in the previous quiz would calculate molar mass wrong because you are, if there's a 2 in the Cl, you would also add the 2 for the Ag. The subscript only goes to the one that is given unless there's parentheses. And like I said, I added this already in my calculator and I got 143.32. So that goes at the top. We got rid of moles of AgCl, so that means I'm multiplying 0.45 times 143.32, and I get 64.494. Now I only want 2 sig figs, because that's what I started with only. So I'm going to round it to just 64, and that would be 64 grams of AgCl. Okay, and that's it. Okay, so how about stoichiometry with mass? Now, again, you're always, and I can't clarify this enough, you're always going from this side to this side, always from left to right. Before we just went, one step, 1, 2, 1, 2, 3, things like that. But now we're always going from one molecule to another molecule. We're never going to figure out like mass of that same molecule over mole of that same molecule, okay? So pay attention to these problems. So it says, how many grams? So we want to know grams of BaOH2. So that's going to be like our little question mark. I always like to put a question mark, and I would like to put the units so I know where I'm ending up. I'm going to find the question mark of grams of BaOH2. That means I'm going to end up here eventually, but I want to know where I'm starting. So this is where I'm going to end up. Are precipitated from 14.5 grams of NaOH. They're telling me I have 14.5 grams of this. Sorry, it's, I know, let's see, 14.5 grams. I have 14.5 grams of this. Okay, so I have 14.5 grams of this. How many of this grams do I make? Okay, this is very key and clear, guys, because listen, you need to have enough of these two in order to make this, right? In order to have a final product. Now, this is something key thing pharmacists do all the time. Chemists do all the time. This is something also like if you're into industry of, you want to create makeup, you want to create perfumes, you want to create something like this. You need to make sure you make that smell or that right scent. But in order to do that, you need to make sure you have enough of your reactants. Okay, so this is a key thing. This plays role in so many different industries. So let's take a look. We have 14.5 grams of NaOH. Okay, so we have 14.5 grams of this, right? So now that means that, guys, I have 14.5 grams. That means I'm starting here and I'm going here. And there's only one path to get there. We have to go from mass to moles, moles to moles, moles to mass. So we're making a little U here. All right, guys. So this is my known again. So these are my NaOH. And then this is going to be my BaOH. NaOH, BaOH. And the only way to get there is this way. So that means since I'm going down, I'm going to use that 1 mole over molar mass. I'm using this fraction. So it's going to be 1 mole of NaOH over my molar mass in grams of NaOH. This, again, remember, molar mass you need to find in your periodic table. You need to figure out Na, you need to figure out O, you need to figure out H. If you look in your periodic table for Na, you get 23. If you look in the periodic table for O, you get 16. If you look in your periodic table for H, you get 1.01. You add this all together, so 23 plus 16 plus 1.01, you get 40.01. Okay, it's 40.01 grams of NaOH. Listen, in order to avoid like rounding wrong or not rounding right, things like that, this is the reason why it's good to just do it all in one step. So I got rid of grams, now I'm at moles. So don't put anything in your calculator yet. Now you're here, you're not done. You have moles of NaOH, but that's not what you want. You want mass of BaOH. So that means that now you're going to make the conversion. NaOH, BaOH. NaOH, BaOH. The only way you can do this is using coefficients. Now, we want to get rid of moles of NaOH. That means moles of NaOH now has to be at the bottom. I want moles of BaOH because I want this now. Okay, and I'm using the coefficients. Remember, coefficients. So NaOH has a coefficient of 2, BaOH has a coefficient of 1. Okay, and now I can get rid of moles of NaOH. Now I'm one step closer. Now I'm at moles. I'm right here. And now I can finally go to mass. And now I can use this top one, molar mass over 1 mole. So that means my molar mass in grams of BaOH2 is going to be at the top. My moles of BaOH2 is going to be at the bottom. Okay, and now remember, so it's going to be 1 mole because the 1 mole is at the bottom. This is the molar mass, just like you did here, but now you're going to do it for Ba. And you have 2 O's, remember, and you have 2 H's. The 2 is not for the Ba, okay? The 2 is not for the Ba. That's a key thing you need to remember. So Ba, you have 137.33. O, you have 16. And you're doing it times 2. H, you have 1.01, and you're doing it times 2. So this would be 32, because 16 times 2 is 32. This would be 2.02. And now you can add all this in your calculator. Remember, since we haven't really done anything in our calculator, it doesn't matter if we clear anything. It's 33, my bad, I forgot a 3 there, plus 32 plus 2.02. You add this all together, and you get 171.35. And just making sure, yep, I added that. I just, it's always good to double check your work, guys. It never hurts. Make sure you added right. Make sure all this looks right, because trust me, you don't want to set up a big problem like this and then one thing be by 1 off or something like that. So see, this is why it's easier to set it up like this, because now you can just input everything. So we're going to start with 14.5 times 1 equals that, divided by 40.01. Okay, equals that. We're going to multiply it by 1. Equals that. We're going to divide it by 2. Equals that. We're going to times it by 171.35. Equals that. We're going to divide it by 1. Equals that. Your final answer is 31.049514. But you want 3 sig figs, because 14.5 is 3 sig figs, so you want to round it to 31.049514. 0.0 grams of BaOH2. In this new stoichiometry, we have volume, okay? And we also have something known as the volume of molarity. So there's two types, volume of solutions and volume for gases. So first we're gonna worry about solutions. For solutions, they're always gonna give you something known as the molarity. So how many moles there is per 1 liter of that solution. This is always gonna be given to you. This is something you are going to use. All right, so let's take a look at now, like I said before, the molarity is something that's always going to be given. So now you're going to actually, in molarity or solution types of problems, you will see two numbers. Don't get freaked out. I'll make sure that you know which one you're going to start with. Okay, it says, and always read the question so you know which one will you start with. It says, if you need 15.7 grams of BaOH2, so that means that we have 15.7 grams of this. Let me use my green pen. We have 15.7 grams of this. Okay, we have 15.7 grams of BaOH2 to precipitate how many liters of 2.5 moles of NaOH, so that means that we have 2.5 moles of NaOH solution is needed, meaning that I am trying to figure out the liters. So I'm going to go to volume and liters of solution. That means I'm going to end up here. This is where I am going to end up because that's the question that's asking how many liters. Okay, so I'm going to end up here. Of NaOH solution is needed. So let's take a look at this. How would we set this problem up? We are starting again with grams. That means that I am starting over here. I'm going to go to moles, I'm going to go to moles, I'm going to go to volume of solution because this is where I want to end up, but they're giving me 15.7 grams of something. They're giving me 15.7 grams of BaOH2. This is BaOH2, this is NaOH over here. So in order for me to get to NaOH, I need to cross the mole to mole ratio first. But first, I have to turn the mass of BaOH2 into moles of BaOH2. So we start off with 15.7 grams of BaOH2. All right, so I am going to go down to moles, and I'm using the top one, which is 1 mole over the molar mass. So 1 mole of BaOH2 over the mass of BaOH2. Okay, so Ba, and remember, you have 2 O's, you have 2 H. You do not have 2 BAs, you only have 1 BA. So BA is 137.33, O is 16.00, and you have 2. H is 1.01, and you also have 2 of that. So how will we do this? We just add this all up together, and 16 times 2, remember, is 32. 1.01 times 2 is 2.02. So we do 137.33 plus 32 plus 2.02, and altogether is 171.35. Okay, and now I have it in moles of BaOH2. So that means that I just transfer from here to here. Now, I want to transfer it into NaOH, so I have to do the mole to mole ratio. I have to use coefficients. So that means that I got rid of my grams of BaOH2. Now I want to get rid, let me just move it closer, of moles of BaOH2. And I want to know the moles of NaOH. That's not the final answer that I want, but it will help. Oops, I don't know why I put a parenthesis there. Moles of NaOH. And now here is where I'm using coefficients. So BaOH2 does not have a coefficient. That means it's a coefficient of 1. NaOH does have a coefficient. That means it's a coefficient of 2. So now I am here. And now I can move down here. So it's always going to be 1 liter over the molarity. So that means that 1 liter always stays, since I'm going down, it's going to be 1 liter of NaOH over the molarity. they told you the molarity. The molarity is 2.5 m of NaOH. Molarity and moles can cross each other off because they actually do refer to the same thing. So these are actually the same units, even though it's a capital M. And now you can just go ahead and go across. So 15.7 times 1 divided by 171.35 equals this, times 2 divided by 1 times 1 divided by 2.5. And you get this as your final answer. So liters, you need these many liters of this kind of 2.5 molar solution in order, if you have 15.7 grams. That's how many liters you will end up having. So it's 0. And remember, since this is 3 sig figs, this is 2 sig figs, I only want 2 sig figs because this is the shortest sig figs. So 0.073 liters of NaOH. Also take the volume of gases. If you look at your stoichiometry mole island sheet, you have volume of solutions, which is what we just did, but you also have volumes of gases. So if you remember our gas laws, remember standard temperature and pressure meant 1 atm or 101.3 kPa or 101,300,000 PA, things like that, at 273 degrees Kelvin. Also, the molar volume, so if at standard temperature and pressure, that means that 1 mole of any gas is equal to 22.4 liters. So it doesn't matter what gas, any molecular gas, the molar mass of that gas at STP at standard temperature and pressure should be 22.4 liters. So like I said before, you can do volume of gases as well. You definitely can take the volume of a gas. So let's take a look at this example. If you need to react 1.5 grams of zinc, so I always, like I said before, I always like to put, okay, I have 1.5 grams of this. This means this is what I'm starting with. What volume, meaning this, so now I know it's going to be liters because volume is always in liters. What volume of H2 will be produced? So what volume of this will I make? Because this is the only H2 here. So now, what does that mean for my mole island sheet? I have grams of zinc. That means I am starting here because this is my known. And now I am traveling to volume of gas because mass to mole, mole to mole, mole to gas. Anytime you deal with a gas, it's always going to be the number 22.4 liters is equal to 1 mole. Okay, so it's going to be mass to mole, meaning mass of zinc to moles of zinc. Moles of zinc, okay, moles of zinc to moles of H2. Moles of H2 to liters of H2. That's my path for this, okay? So let's start off by writing what I have, which is 1.5 grams of zinc, Zn. All right. So now, how would this look? So now I want to know, so I'm going from moles of zinc to grams of zinc. That means that 1 mole of zinc is going to be here. Grams of zinc is going to be here. This is going to be my molar mass of zinc. Since there's no addition, zinc is by itself. There is no other element with it. So I am just going to find the mass of zinc, which is 65.39. This is a fairly simple and easy one. Okay, there is no molar mass that I have to add up. Now, I am mass of zinc to moles of zinc. Now I can turn those moles of zinc to moles of H2. That means that moles of zinc is going to be at the bottom because that's what I want to get rid of. And moles of H2 is going to go at the top. Remember, this is where coefficients come in. Does zinc have a coefficient? No. So it's going to be 1. Does H2 have a coefficient? No. So it's also going to be 1. And you keep going. Now, I have gotten rid of my moles of zinc. Now, where do I want to go next? Remember, you want volume of the gas, a volume of hydrogen. That means I'm using the top one because that's the one that's pointing up. So it's going to be 22.4 liters of H2 over 1 mole of H2. Oh, not L. Sorry. H2. All right. So now I can get rid of moles of H2 and I will finally have my answer in the desired unit. And now this simply becomes, again, multiply by the top, divide by the bottom. So it's 1.5 times 1 divided by 65.39 times 1 divided by 1 times 22.4 divided by 1, which gives me 0.5138. Now, I only want 2 sig figs because 1.5 is only 2 sig figs, so it's going to be 0.51 liters of H2. So let's take a look now at the let's practice, guys. There's a lot of let's practice. Listen, what I would do if I were you is I would pause it every time I do a let's practice. Pause it, try to do it yourself, and then look at the video to see if you did it right, okay? It's the best way to practice this, but I'm going to go ahead and start with this one. It says if you are making 0.57 moles of H2O, that means that I have 0.57 moles of this. How many moles of O2 do you need? So how many moles? So this is a mole to mole, as you can see. Okay, it's a one-step problem. So always start with what you have. You have 0.57 moles of H2O. All right, that's what you have. That's what you start. You're starting off here. You want to know the moles of O2. So you're going from mole to mole. You're just simply using coefficients. You want to get rid of the moles of H2O. That's going to go at the bottom. You want moles of O2 that goes at the top. And you just put in the coefficient. H2O has a 2. O has a 1. You multiply by 1, divide by 2. So you just take your calculator. And you do 0.57 times 1 divided by 2, that gives you 0.285. So you want only 2 sig figs, so that would be 0.29. And moles of H2O you get crossed out, and you get moles of O2. So let's take a look at the let's practice 2. It says, if you need to precipitate 10.7 grams of BaOH2, how many grams of NaOH are needed? So let's start with what we have. We have 10.7 grams of this. Okay, 10.7 grams of BaOH2. How many grams of NaOH are needed? Meaning, how many of this do we need in grams? So as you can see, we have grams and we're going to grams. So that means this is a simple gram to gram. So if we look, we're going to go mass to mass. Mass of the known, which is BaOH, to the mass of the unknown, which is NaOH. Okay, so let's start with by writing what we have. We have 10.7 grams of BaOH2. Okay, and we want to get rid of grams of BaOH2. And we want to turn it into moles of BaOH2. Okay, so remember, again, and by the way, we've done this one before. If we take a look at this, let me just go back to previous examples, and I'm just going to go use it from previous examples. If you remember, basically 1 mole is equal to 171.35. And again, I just used it from the previous notes. So 171.35 is equal to 1 mole of BaOH2. And we're going to keep going. Now that we know how much 1 mole of BaOH2 is, now we're going to go into moles of NaOH. Okay, and we're going to use the coefficients. And remember, because we want to get rid of moles of BaOH2 now, that's going to go at the bottom. And the moles of NaOH are going to go at the top. And we're going to use the coefficient. This doesn't have a coefficient. Let's get to 1. This has a coefficient. That gets a 2. And we keep going. Okay, now that we have, so we went from here to here, and now we're here, from here to here. Now we can go into the mass of NaOH by using the molar mass over the 1 mole. So we want to get rid of moles of moles of NaOH. So moles of NaOH is going to go at the bottom, and remember that's that 1 mole over the molar mass of NaOH. And by the way, again, We've used NaOH before, and I'm just going to use it from what we have. 1 mole of NaOH is equal to 40.01. Okay, so that means that 40.01 is going to go at the top. And that way we get rid of moles of NaOH. And now this simply becomes just put it in your calculator, see what you get. 10.7 times 1 divided by 171.35 equals times 2 equals divided by 1 times 40.01. And then divided by 1. And you get 4.9968719. How many sig figs do we want? We want 3. So that means if we round this, we should get 5.00, because 4.99 rounds to 5.00 grams of NaOH. All right, so let's look at the let's practice 3. It says, how many moles of AgNO3 are needed to react with 10.7 grams of CaCl2? So you're going to first look at what you have. You have 10.7 grams of CaCl2. That means that we have 10.7 grams of this, guys. Okay, we have 10.7 grams of this. And we want to know how many moles of AgNO3, meaning how many moles of this do we need? If we have 10.7 grams, how many moles of this do we need? All right, so let's take a look at that. So let's start by writing what we start with. So we start with 10.7 grams of CaCl2. So that means that, again, we're starting here. And we want to have moles of AgNO3. That means that we're going to end up at these moles. Not these moles, but these moles, okay? Because we're always going towards unknown. So we want to know the grams of CaCl2 over 1 mole of CaCl2. How come I know I use this one? Because remember, since we're going down, 1 mole's at the bottom, the molar mass is, the 1 mole's at the top, sorry, the molar mass is at the bottom. So we're going to find out what Ca and Cl2 add up to. So Ca, we look at our periodic table, it's 40.08. Cl2 is 35.45, but we have 2 of those. So let's take a look at what our math would be. 35.45 times 2, that's 70.90. And that means that we're going to add it to 40.08. That's 110.98 as a total. 110.98. Right? So, and we keep going. Now we got rid of grams of CaCl2. We have moles, but we don't have the moles that we want. We have moles of CaCl2, which are here, but we want moles of AgNO3. So we're going to put moles of CaCl2 at the bottom here. We want moles of AgNO3 at the top there. And we're going to use the coefficients. Remember, that's the coefficient. That's the numbers in front here. So 2 for AgNO3, 1 for CaCl2 because it doesn't have one. So now we can simply do the 10.7 times 1 divided by 110.98 equals times 2 divided by 1. And we get 0.1928 and so on and so forth. We want 3 sig figs because 10.7 is 3 sig figs. So it's going to be 0.193 not grams, my bad, moles of AgNO3. All right, because we got rid of moles of CaCl2. All right, and now let's look at the last let's practice 4. It says, if you produce 15.4 liters of H2, so guess what, guys? We have 15.4 liters of this. At STP, how many grams of zinc chloride is also produced? Meaning, how many grams of this can I produce? So I start with liters, and I'm going to go into grams. What does that mean, guys? Normally, I start here, or I've started there, but now I'm starting here, okay? And they wanted me to figure out the grams. So I'm going to go from volumes of H2 to moles of H2, then moles of H2 to moles of zinc chloride, then moles of zinc chloride to mass of zinc chloride. So let's start off by writing what we have. We start off with 15.4 liters of H2. Okay, so we look at this, we're going from here to here. That means that we have 1 mole over 22.4 liters. 1 mole of H2, 22.4 liters of H2. Okay, so now if we do that, we get rid of liters of H2, and we have moles of H2. But now we want to go from moles to moles. So now we want to get rid of moles of H2 because we want the moles of zinc chloride, of ZnCl2. Now we use coefficients. As you can see, none of them have coefficients, and it's the 1-to-1 ratio. And we keep going. We got rid of moles of H2. We got rid of moles of H2. Now we can finally go to the mass of zinc chloride. Okay, so that means that the molar mass, so that's going to go at the top. Oh, let me give it some room there. I did not give it enough room. Grams of zinc chloride over 1 mole of zinc chloride. Okay, so we're going to look at zinc. So Zn is 65.39. And chloride, we have 2, so that's 35.45 times 2. That's 70.90, and we're going to add it to 65.39, and my total there is 136.29. Okay, all right, so now we got rid of moles of zinc chloride and rid of moles of zinc chloride. Now we just go across. So we're going to do 15.4 times 1 divided by 22.4 times 1 divided by 1 times, let me start over. Sorry about that. 15.4 times 1 divided by 22.4 times 1 divided by 1 times 136.29 divided by 1. I got 93.699. So I want 3 sig figs, so that means my answer would be 93.7 grams of zinc chloride. Also, limiting reactants is when, let's say, for example, we have 2 less of one reactant, meaning something in the reactant side, and it's gonna run out. This is known as a limiting reactant. So limiting reactants are anything that runs out during a chemical reaction. This limits how much product can really be made. So one of your reactants is always what we call a limiting reactant. And then the other reactant then is said to be an excess, meaning it won't run out as fast as the other reactant. Okay guys, so let me tell you, this problem is probably the lengthiest problem you will see in stoichiometry. Now, with that being said, it's not any different, however, than what we've already been doing. The reason it's so lengthy is because you have to go through the process twice in order to figure out which of your 2 reactants is what we call the limiting reactants. So if you remember, in a formula, the reactants are to your left-hand side, your products are to your right-hand side. So it's telling you here, you have 14.5 grams of AgNO3. So we have 14.5 grams of this. We also have 14.5 grams of this. How many grams of AgCl? So how many grams of this will be produced? Which one would be your limiting reactant? So you wonder, okay, what do I start with? How do I tackle this? I have 2 numbers now. Molarity gave me 2 numbers, but I only used it for when we were trying to figure out the liters of something. So guess what? You're going to have to do this twice, which means that first you're going to start with this one, and you're going to figure out how many grams of AgCl you made. Then you're going to get a number there. Then you're going to start over, you're going to grams of this one and see how many grams of this one you make. You're going to compare the 2 numbers and see which one made less grams of AgCl. Whichever one makes less AgCl, that is your limiting reactant. So again, let's start with AgNO3 first. So we're going to start with that, and it's going to be 14.5 grams of AgNO3. All right, and that means that, again, this is a mass to mass, both times. So mass to mass, mass to mass. First, we're going to start with mass of AgNO3 to moles of AgNO3. We're going to use the top one, which says 1 mole over the molar mass, so grams of AgNO3. So this is where you figure out what would be the most. So Ag, if we look in our periodic table, is 107.87. N in our periodic table is 14.01. O, we have 3, so that's 16.0 times 3. All right, so we're going to do the math here. 16 times 3 gives us 48. And we're going to add 48 plus 14.01 plus 107.87 to give us a grand total of 169.88. That is the molar mass of AgNO3. Okay, and again, always check your work. Make sure it does look right, and it is right, but always check your work, okay? Now, we have moles of AgNO3. That means that we just went from mass to mole. Now we can go from mole to mole, meaning we're going to go from moles of AgNO3 to moles of AgCl. We always go to the question mark. So we have moles of AgNO3, because we want to get rid of that, to moles of AgCl. And we're going to look at the coefficients. This is 2 to 2, so it's 2 and 2. Okay, and we keep going. Now that we're going to have moles of AgCl, but now remember, we want grams of AgCl. We don't care about the moles of AgCl. Okay, so that means that I want to get rid of moles of AgCl. That means that 1 mole is going to be at the bottom, like it says here. The molar mass is going to be at the top. So now I am going to do the same thing that I did at the top here, but now I'm going to do it for Ag and Cl. And Ag we said is 107.87. Cl, I just remember, is 35.45. Let me just double check. Yep, and I'm going to add those together. Plus 35.45. And that's 143.32. That's grams of AgCl. Okay, and now you just put everything in your calculator. So you're going to start with 14.5 times 1 divided by 169.88 times 2 divided by 2. Okay, times 143.32. Oops. Divided by 1. And you should get 12.2, and then you get more numbers. Remember, you only want to round it to 3 sig figs, so we're just going to leave it at 12.2 grams of AgCl. Now, ladies and gentlemen, you are not done. This is one number. You now have to figure out how much AgCl now you make from BaCl2. And you have to start this all over again, but now you're going to start with BaCl2. So remember, you still have 14.5 grams of BaCl2. And you're going to do the same process. You're going to have 1 mole of BaCl2, and now you have to figure out Ba and Cl, and you have 2. You have to figure out that math. So Ba is 137.33. Cl is 35.45. You have 2, so that's 70.90 plus 137.33. And you have 208.23. Yep. All right. And you have moles of BaCl2. You're going to keep going here. All right. Sorry, make sure it's up there. All right. You're going to keep going. So now you have grams of BaCl2. Oh, my bad. This is supposed to say grams, not moles. Grams of BaCl2. Now you have moles of BaCl2. So now you want to now you're here. Now you want moles of AgCl. Again, you're transferring to the same thing. You're still going to AgCl, and you're going to get rid of, sorry, my bad. I keep writing the wrong things. This is moles of BaCl2 because you want to get rid of that, and you want moles of AgCl. Like I said, AgCl has a 2 coefficient. Let's see what BaCl2 has. BaCl2 does not have a coefficient, so that's a 2 to 1 ratio, and we keep going. Now, we got rid of moles of BaCl2, and this ending is going to be exactly the same here. There's really no new math that you need because it's still transferring to the same AgCl and over 1 mole of AgCl, so this still looks the same. And now we got rid of moles of AgCl, and now we can start here, okay? Now we start with 14.5 times 1 divided by 208.23 times 2 divided by 1 times 143.32 divided by 1. And as you can see, we make 19.9600. Okay, we want only 3 sig figs. That means it's going to be 20.0 grams of AgCl. So now we have to decide which one is less, and that's kind of pretty simple. You know 12.2 is less than 20. So then which is your limiting reactant? The last thing you have to write is then AgNO3 is my limiting reactant. And that is it, and you are done. So guys, that was the last video. That's basically the wrap of chemistry for this year. Unfortunately, we had 3 other chapters, but because of time purposes and the fact that you guys are map testing, and also some of you guys are going to take the AP Spanish test, I just want to leave it at that. Please watch this video. It's very important. Stoichiometry is not an easy thing to learn. Definitely a lot more difficult than any other section. I've told you guys, I think, since the beginning of the year about this. This quiz, I will have it up by next week on Thursday, basically, because it's next week we are switching days. Monday and Thursday is going to be your B days. This will be up by, quiz will be up by next Thursday, May 14th. That means that office hours will be on May 11th on Monday. If you guys have any questions, please feel free to ask questions. But after that, you guys will not have any assignments. Just make sure you take care of all your quizzes. This quiz is going to be exactly like the previous quizzes where multiple choice, you submit your work, you get half the credit for the work, half the credit for the actual quiz. And that's it. Honestly, it's been a great year. Unfortunately, we had to end this way. If you guys want to just stop by office hours to just say hi or say goodbye or whatever, that would be greatly appreciated. Miss Nichols will also have her office hours. Again, hope you guys have an amazing summer, and hopefully I will see you next year.